Example 7, section 2.1. So this example is dealing with a set of cards, and just for people who may not be familiar with this, there are 52 cards in total. There are 4 suits, they are called, clubs, spades, hearts, and diamond. 2 of these suits are black colored, and 2 of these suits are red colored. So there are 26 black color cards, and there are 26 red colored cards. There are 13 cards in each suit, 1 through 10, and there's a Jack, Queen, King, and those Jack, Queen, Kings of each suit are what we call face cards. They have a face on their cards. This example is going to take us back to Unit 1 with set theory, and we were introduced at that time of the principle of inclusion and exclusion. We found the number of elements in the union between 2 sets is the number of set A plus the number of set B minus the number in that overlap, in that intersection. So when there is an intersection, we say that they are not disjoint. There is an overlap. And we also had the number of the union of 2 sets was the number of A plus the number of B if they were disjoint sets. That meaning there was no overlap between the 2 sets. So let's continue. Question is, count the number of possibilities of drawing a single card and getting either a black face card or an ace. So the first thing we're going to look at is whether these represent a disjoint set or not a disjoint set. Is there an overlap or is there not an overlap? So our black face cards represent Jack, Queen, King of both suits, clubs, and spades. So there are 6 items in total. The aces are the ones of each suit, and there are 4 of them. As we can see from the picture, there is no overlap. They are distinct sets. So to find the number of outcomes or possibilities, either containing a black face or an ace, we can write the number in the set of a black face card or an ace is the number in set B plus the number in set A. The number of black face cards, there are 6 possible outcomes, and there are 4 aces. This will give us 10 possible outcomes. The next question we're going to look at is either a red card or a 10. So what is the number of possibilities of drawing a single card and getting either a red card or a 10? So this question is a little different because some of those red cards will also be a 10 card. And we can kind of see that in the diagram below. If we look at the red cards, there are 26 red cards in total, including the hearts and the diamonds, 13 of each suit. The number of 10 cards we have is, yes, there are 4 10s in the deck of cards, 1 from each suit, but we can easily see that 2 of those cards, the 10 of hearts and 10 of diamonds, belong to both sets. So these 2 sets have an overlap. So to count the number of possibilities in this question, we are going to find the number of red cards, or the union of being a 10 card is the number of red cards plus the number of 10s. But in this case, there is an overlap, so we need to subtract that intersection, or intersect T. The number of red cards we have, there are 26. The number of 10 cards, there are 4. And we are going to subtract the overlap. There are 2 cards with both characteristics. So in total, there are 28 possible outcomes.